Question number 4, determine whether the true biconditional can be written from each conditional statement. If not, give a counterexample. So we have our conditional. We want to know if we can write a true biconditional statement. So question A, if the lamp is unplugged, then the bulb does not shine. So let's check the conditional first. If the lamp is unplugged, then the bulb does not shine. So is that a true statement? Can you think of a way where the lamp could be unplugged, but then the bulb does shine? So that's going to be a true statement. All right, to the converse, we'll flip the hypothesis and the conclusion. So the lamp is unplugged and the bulb does not shine. We're going to flip those two statements. So if the bulb does not shine, then the lamp is unplugged. True or false? Once again, if it's false, think of a counterexample. That would be false. A bunch of different counterexamples here. So we're going to say that the biconditional is false. And our counterexample is going to be the bulb burnt out. Therefore, the bulb does not shine, but the lamp could still be plugged in. So it makes this part true and that part false in our converse when we flip them. Try part B on your own. All right, so you'll see my answer here. This time the conditional is false. So if the date can be the 29th, then it is not February. So our counterexample for that is going to be leap year, right? In leap years, then the date can be the 29th, and it can still be February. Our converse, so we could just stop right there to the biconditional is false, because remember, as soon as one of them is false, then you know the biconditional is false. But let's just check the converse real quick just for fun. So if we flip this, saying it is not February, then the date can be the 29th. So if it is not February, then the date can be the 29th. And that is a true statement, right? Because if it is not February, let's say it's May, then we could have a May 29th. And that would make sense. Question 5, write each definition as a biconditional. So remember, you need that if and only if in your sentence. So a cube is a three-dimensional solid with 6 square faces. So we're going to say something like, if a figure is a cube. So a figure is a cube. That's my first part. And then we'll say our if and only if. That's what makes it biconditional. Then we need the rest of the sentence. The figure is a three-dimensional solid with square faces. All right. So once again, we ended that with if and only if the figure is a three-dimensional solid with 6 square faces. All right, forgot the word square there. So with 6 square faces. All right, try parts B, C, and D on your own. Make sure you pause the video, see if you can figure those out. All right, and let's go over the answers. So for part B, I am breathing and I am alive. So I can say that first part, I am breathing, if and only if I am alive. So remember that IFF stands for if and only if. You passed the exam with a score of 60% or higher. So you passed the exam, if and only if you get a score of 60% or higher. So we've got our first part, our hypothesis, and then our conclusion. So we just say the hypothesis, if and only if, conclusion. And last part, D, x plus 3 equals 10, if and only if x equals 7. All right, nice job. Hopefully you found a hidden hack clue as well. If not, maybe rewatch the videos, see if you can find them. Make sure you guys are ready, and we will just do a quick summary on Thursday when we do 2.5.